What is Old Math World? In this video we're going to solve some equations that involve logarithms, and to solve these equations we're going to have to use the algebraic properties of logarithms. So let's just jump into a few of them, and I think if you haven't done this before you'll get the gist of it after I work through a few of them. So the first thing I look at here, I got this equation here. Log base 4 of x plus 4 minus log base 4 of x minus 2 equals 3. And I need the same base here. That's very important, and then I'm subtracting. So as long as I have the same base and I'm subtracting, I can rewrite this as log base 4 of x plus 4 over x minus 2 equals 3. And now with the definition of a logarithm, what this means is that 4 raised to the third, so this implies that 4 raised to the third, that's been an implication symbol too, 4 raised to the third equals x plus 4 over x minus 2. Okay? And now to solve, now we just solve for x. And we got that x minus 2 in the denominator down there, so to get it out I need to multiply by x minus 2. But I need to do it to both sides. Okay? So that's going to be, what is 4 cubed? 4 times 4 is 16, times 4 is 64, I believe. So 4 cubed, 64. Good. So that's going to be 64x minus 64 times 2 is going to be what? 128. 28 equals, and over here those two cancel. I'm leaving with x plus 4. Okay, get all my x's on one side, so I'm going to take this x over to the, I'm going to take this x over there and take this 128 over that way. So it's limited 64x minus x is going to be 63x, and add 128 to both sides, and we get, what's 4 plus 128? 132. And so therefore x equals 132 over 63. I don't think there's going to be any simpler form, any simpler way to write that. Is there? Can I divide both by 3? Let's see. 3 goes into 13. 4 times remainder 1. 43. I mean 44, I'm sorry. 44 over 21. Is that going to be the best I can do? Let me make sure. 132 divided by 3. Yeah, good. 44. So 44 over 21. And 7 or 3. Nope. So I think that's going to be the nicest answer I get there. 44 over 21. Okay? Let's jump to another one. Here I've got the log base 5 of x plus 4 plus the log base 5 of x plus 2 equals 2. Again, I check that I have the same base. If I don't have the same base, I can't use the properties of logarithms unless I do a change of base. And I'm adding, that means we're multiplying inside the logarithm. So this is going to imply that the log base 5 of x plus 4 times x plus 2 equals 2. And now, definition of a logarithm, 5 squared equals that which is inside the logarithm. So it's going to give me that 5 squared, which is 25, equals x plus 4 times x plus 2. So that's going to give me that 25 equals x squared plus what, 6x plus 8. Alright, now we get 0 equals x squared plus 6x. What's that going to be? Negative It's negative 17. 17, 18, 19, 20, 21, 22, 23, 24, 25. Yep, that's good. And does this thing factor nicely? 17, surely not, right? So let's break out the quadratic formula, right? So it's the x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. How are we looking on time? Okay, 5 minutes, so we're good. Negative b is going to be a negative 6 plus or minus the square root of b squared, 36, minus 4, and then that c is a negative, so that's going to be plus 4ac, so 4 times 17, 28, 2, so 68 I believe. Let me make sure. Yep, good, 68. All divided by 2a. And so that's just going to be 2. And let's see, what will we get here? Negative 6 plus or minus square root of 8 and 6 is 14. Carry the 1, 6, 7, 8, 9, 10, 104 all over 2. Okay, and let's see, does 104 have any perfect square factors? Let's see, 4, so 104 surely divided by 4, 26, and 26 I don't think it has any perfect square factors. So that is, this is going to equal, negative 6 plus or minus 2 times the square root of 26, where that 2 is the 4 inside here, 4 times 26 to give me 104, all divided by 2. Alright, so that's going to equal negative 3 plus or minus the square root of 26. Okay, so negative 3 plus or minus the square root of 26, and then you got to check inside here to make sure that you're not taking the log of a negative number. You can't raise 5 to any power and get a negative number. So I believe if we leave that negative 3 minus the square root of 26, that's going to be a negative number bigger than 2, so that's not going to be a valid answer. So I think our final answer is going to be x equals negative 3 plus the square root of 26. Okay. Let's see. Maybe we've got time for one more. Let's go here. So log base 9 of 13x divided by log base 9 of 4x equals 2. Let me just knock this thing out. Let's use yellow. We haven't used that in a while. So I've got that log base 9 of 4x in the bottom. I need to get it out. Multiply both sides by that, and we get log base 9 of 13x equals 2 times log base 9 of 4x. Okay? Now I'm going to have log base 9 of 13x. I notice here that I have a base 9. I have two things equal, and they're both log base 9. So if I can get that 2 out of there, I can just set the things that I'm taking the logarithm. Let me just do it. Hold on. So this equals log base 9 of 4x squared. That is, I brought the 2 up there. So we get that. Now I have log base 9 of something equals log base 9 of something. Thus those somethings must be equal. That is 13x must equal 4x squared. That is 13x must equal 16. x squared. Alright, that's going to give me that 16 x squared minus 13x equals 0. Factor out the x, and what do we get? X times 16x minus 13 equals 0. So we get x equals 0, or x equals 13/16. Now you got to check your answers. So can I plug a 0 in here? Can I take the log base 9 of 13 times 0, which would be the log base 9 of 0? That would be 9 raised to what power equals 0? I can't do that, so that gives me a bad answer. So my final answer is going to be x equals 13/16. I think, yeah, that's going to do it for this one. We're pushing it. Alright, hope it helps you out.